Scientists' perspective of the solar system has changed dramatically since NASA's Juno probe arrived at Jupiter in July 2016. The $1 billion mission not only captured breathtaking photographs of the gas giant from hundreds of millions of miles away, but also used a suite of advanced instruments to uncover some of the planet's deepest, darkest secrets. This raises fascinating questions. What exactly has Juno discovered about Jupiter? What have other spacecraft revealed in past missions? And why have the latest findings left scientists completely baffled? Often referred to as the king of planets because of its sheer size and dominance in the solar system, Jupiter has long fascinated humanity. Its brilliance shines against the night sky, a spectacle that ancient civilizations honored in their own way, attributing kinghood to the mighty world. Exploration of Jupiter has been ongoing for centuries, yet it remains as compelling today as ever. The planet takes about 12 Earth years to complete one full orbit around the Sun, a lengthy year that results from its immense distance of 483 million miles, 778.5 million kilometers. The farther a planet lies from the Sun, the longer its orbital journey. For long-term sky watchers, Jupiter appears to linger in front of each constellation for about a year before moving on. Despite its long orbital period, the gas giant rotates at incredible speed. A single revolution on its axis takes only about 9 hours and 55 minutes, giving Jupiter some of the shortest days of any planet in the solar system, even as it has one of the longest years. Cloud belts and zones form on Jupiter as different sections of its atmosphere rotate at varying speeds, creating powerful winds that sculpt and shape the planet's clouds. Jupiter is the most massive planet in the solar system, with a mass 2.5 times greater than that of all the other planets combined. Its immense size gives it a gravitational force 2.4 times stronger than Earth's. In terms of scale, Jupiter truly lives up to its title as the king of planets, with a diameter of about 273,000 miles, 439,264 kilometers, and a volume large enough to contain the mass of 318 Earths. Unlike Earth's atmosphere, which covers the surface and oceans, Jupiter's atmosphere extends deep into the planet itself, reaching the core. As pressure and temperature rise, hydrogen changes form, first becoming liquid, and then, closer to the core, transforming into a metallic liquid that surrounds a small rocky center. Adding to its complexity, Jupiter is orbited by a swarm of moons. Planetary scientists have identified more than 60 small bodies around the planet, though the true number is likely at least 70. Among them, stand out as the largest and most well-known: Io, Europa, Ganymede, and Callisto. The rest are smaller, many of which are believed to be asteroids captured by Jupiter's powerful gravity. From a young age, most of us learned that all planets orbit the Sun in neat, separate paths. But while Pluto's reclassification as a dwarf planet was shocking enough for many, there is an even more surprising truth. Jupiter does not actually revolve around the Sun in the same way as the other planets. Yet it still follows an orbit, just in a very different way. None of the planets in our solar system revolve around the Sun in a perfectly circular path. In reality, the Sun and its planets all orbit around a common gravitational point. Because the Sun is so much larger than Earth, our center of gravity lies very close to the Sun's center, creating the illusion that we are simply circling it. This is true for every planet, except for Jupiter. The gas giant is so massive that it disrupts this balance. Jupiter's immense size pulls the solar system's center of gravity away from the Sun's middle to a point about 30,000 miles above its surface. As a result, both Jupiter and the Sun orbit this shared location in space, known as the barycenter. Unlike the smaller planets, Jupiter does not revolve directly around the Sun. Instead, its powerful gravitational influence causes the Sun itself to wobble slightly as they dance around this common point. While all planets have a gravitational tug on the Sun, Jupiter is the only one large enough to make this effect significant and noticeable. Contrary to what many people think, Jupiter also has its own ring system. If asked to draw the planets, most would sketch only Saturn with rings, but in fact, Neptune, Uranus, and Jupiter all possess them. Jupiter's ring system is faint and far less dramatic than Saturn's, consisting mainly of fine dust particles. The existence of these rings was first confirmed when Voyager 1 captured an image of them in 1979. According to experts, much of the dust likely originates from impacts on some of Jupiter's smaller moons, which constantly replenish the rings. Jupiter has long fascinated astronomers, and it was Galileo who first observed it through his telescope in the early 1600s. What he saw, the planet itself and 4 of its largest moons, left him stunned and laid the foundation for centuries of exploration and discovery that continue to this day. When Galileo first studied Jupiter, he was astonished to see 4 small moons orbiting around it. As telescopes improved, astronomers were able to observe Jupiter's cloud belts and atmospheric zones in greater detail. In the 20th and 21st centuries, spacecraft flew past the gas giant, capturing clearer images and more valuable data. The Pioneer and Voyager missions were the first to conduct close-up investigations, followed by the Galileo spacecraft, which orbited Jupiter and carried out in-depth studies. Later, the Cassini probe, on its way to Saturn, and the New Horizons mission, en route to Pluto, also collected data during their flybys. The most extraordinary mission, however, has been Juno, launched specifically to study Jupiter's poles. Before Juno's arrival in July 2016, no spacecraft had ever photographed the poles from above or below. Juno's flybys stunned scientists with high-resolution images, revealing vast storms and an unexpectedly blue sky unlike anything seen on Earth. Surprisingly, Jupiter's familiar bands and zones were not visible at the poles, making the planet almost unrecognizable. Further analysis showed that Jupiter's weather system is far more complex than previously thought. Juno's instruments peeled back the planet's atmosphere like layers of an onion, uncovering hundreds of kilometers of hydrogen, helium, and other chemicals. The belts and zones do exist but begin deep within Jupiter, over 1,900 miles below its gaseous surface. NASA also released breathtaking infrared images of symmetrical storm clusters, which, when combined into 3D models, highlighted differences in brightness and temperature. Juno's data further suggested that Jupiter's Great Red Spot indicates the planet may be rich in water. While many of Jupiter's moons, such as Europa, are believed to hold vast oceans, the gas giant itself appears dry at the surface, making it difficult to confirm the presence of water molecules. Through its close flybys and powerful instruments, Juno is helping scientists tackle this mystery by combining its findings with data collected from Earth-based telescopes, offering humanity an unprecedented glimpse into Jupiter's hidden secrets. The Great Red Spot, observed through telescopes, has given researchers a more detailed glimpse into Jupiter's mysterious atmosphere. Their studies suggest that the planet may contain 2 to 9 times more oxygen than the Sun, an element crucial for the presence of water. Scientists also believe that Jupiter might have a fuzzy core, much larger than previously thought. Unlike Earth, which has a solid core surrounded by a liquid outer layer, Jupiter's interior appears to consist of hydrogen in a semi-gaseous, semi-dissolved state, creating its fuzzy composition. This unusual core could be the driving force behind Jupiter's powerful magnetic fields and dynamo, similar to Earth's metallic dynamo, although earlier theories claimed the fields were powered by hydrogen compressed into a metallic liquid state. Even today, experts remain uncertain. Adding to the mystery, Jupiter's auroras have baffled scientists by producing 10 to 30 times more energy than expected, mostly in ultraviolet light invisible to the human eye. Unlike Earth's auroras, which are driven by solar particles interacting with magnetic fields, Jupiter's appear to be influenced by an enigmatic plasma field. Interestingly, the auroras also dim when the planet rotates into darkness, a phenomenon yet to be fully explained. Beyond Jupiter itself, NASA's Juno spacecraft discovered evidence of a previously unknown volcano on Io, one of Jupiter's moons. Infrared imaging revealed signs of volcanic activity, adding to the estimated 150 active volcanoes already known on Io. However, the massive amount of material ejected into space suggests there could be as many as 250 more hidden volcanoes waiting to be confirmed. These discoveries serve as a powerful reminder of how vast and mysterious our universe truly is, and how much more there is still left to uncover.